In this tutorial, I want to show you how to change colors in R. I will start with the basic plotting function and then move on to ggplot, where we are able to map the color to a specific variable. I will show you different scale functions that can modify this mapping. I will introduce you to the RColorBrewer package and show you different functions that can turn RGB colors into hex code and turn color names into RGB values. I will give you examples on how to create different gradients in R and show you how to change the color in text or in the axis of your charts. And in the end, I show you the Paletteer website, where you will find over 2000 different color palettes. If you like this content, subscribe to the channel and give this video a thumbs up. Now let's go ahead and jump into the R code. First, I want to show you how you can change the colors with the plot function that's part of the base package, just in case you're not using ggplot yet. Here you will need a vector of x values, y values, and then a vector that contains the color information. Let's take the empty cars dataset, where we can plot the weight of cars on the x-axis and the miles per gallon on the y-axis. We can change the point character from an empty circle to a fulfilled dot, and also change the axis labels with the LAS equals 1 function argument, and then the chart changes to this. And if you add col equals red in quotes, you can change the colors of the dots to red. And what's going on in the background? In theory, the plot function needs a vector of x values and y values, and if you just specify one item instead of a long vector, it will replicate that item as many times as the previous vectors are in length. In R, this replication is called recycling, and you will notice it when you hand over a vector of 2 values. It will switch between red and blue until it matches the length of 32 items. Now, if you want your colors to be more meaningful and represent something from the dataset, you want to hand over a vector that contains valuable information that's then used for the coloring of the dots. And we can do that by adding a new column to the empty cars dataset called colors AM, which will represent a color for a different method of gear shifting, whether it's automatic or manual. And whenever it's a 0, which would be the case for 19 of the 32 rows, we can set that to red. So now we have a few red items, and we can do the same with manual shifting, setting them to blue. And now this change of red and blue in color will match the weight and mileage of certain cars, which means that when we hand over the whole vector that we now created to the color function argument, we get this chart where we have the cars with manual gear shift here in blue and the automatic gear shift in red. We could do the same thing for the cylinders. There are cars with 4, 6 and 8 cylinders, so we can create a new column called color cylinder where we code 4, 6 and 8 with red, blue and green. So now we have green, blue and red within this new column, and if we plot it by handing over this column or vector of colors to the color function argument, you'll see this picture. Now it is helpful to add a legend, which you can do with the legend function. This function needs an x and y argument that indicates where the legend should be placed. So I put it on 4.5 and 33. That's for the left corner of the legend. Then you give it the labels that you want to see, 4, 6 and 8 cylinders, and the colors that were used to encode those, red, blue and green. You hand over the point character to indicate these dots. You can add some factor to increase the size, and then you can also hand over a title, here cylinders, and give it a background, in this case light gray. In case you're wondering which colors are available by name in R, you can use the colors function and then scroll through 657 different colors by name. So in case you want to change the blue for 6 cylinders to purple, just override it and then plot it again, and the blue turns into purple. Now there's something I want to point out quickly. If you use point character 16, you have these dots where the color fills out the filling of the circle as well as the stroke. So it's just one dot where you cannot really specify the difference. The same happens with point character 1. You just have this outside stroke and an empty circle. But there are point characters where you could actually have a difference between the filling and the stroke, 21 till 25. And if you use 21 and specify color, it will only color the outside, and you could use black for that, for the outside stroke, and then use the actual color for within the point character with the bg function argument. And this you can do for point characters 21 till 25. At least that's the way how it's done with the plot function. For ggplot you will have color and fill function arguments colors available. Now, if you don't want to create these specific color vectors, but just use the information that's already there is of course a way you can do that. So for example, you can hand over the cylinder column all by itself, but what it does, it uses the cylinder numbers as the color coding. So this is 4, 6, and 8, indicating blue, pink, and gray. If you don't want to have those numbers, but the default first 3 colors, you can change the numeric values into a factor with the factor function. And then you get 1, 2, and 3, color coding black, red, and green. If you use factor on the cylinder column of empty cars, it looks like nothing has changed and you still have 4, 6, and 8 as levels. But if you would turn those first 3 levels into numeric values, you can see that they are coded with 1, 2, and 3 in the background. And I can prove this further by plotting 50 dots in 5 rows and 10 columns. And for color, I use the numbers 1 to 50. And you can see that the first 3 are actually black, red, and green. And the previous 4, 6, and 8 indicated blue, pink, and gray. And then after the first 8 colors, it just repeats. So by default, there are just 8 colors within the plot, unless you specify them differently by name. So there's no difference using color 10 or color 2. It would both result in this red color. Now, one final example for the plot function. Imagine you want to represent 2 different variables of your data set with different colors. For example, the cylinders and a gear shift. You could color them with a light and a dark version. So you use red for 4 cylinders automatic, but then dark red for 4 cylinders, but the gear shift being manual. You repeat the same for 6 cylinders with a light blue and a regular blue. And then for 8 cylinders, use green and dark green to represent these different combination of values. Then you would get this color vector, which now holds 12 times green, which is 8 cylinders and automatic shift. And if you plot this, you would see that within the red 4 cylinders, the darker version, the manual shift, tends to be within lighter cars. Same for the 8 cylinders in green and the 6 cylinders in blue. But a better way to do that, representing 2 variables in a plot, is actually not by colors, but by using different shapes. So for example, you could use the cylinder colors as before, red, purple, and green, but for the point character, use the automatic manual column, which is then translated into circles and squares. And for the final chart, I used the factor again on cylinders and handed over the legend arguments, where I pasted automatic to the 4, 6, and 8 cylinders and repeated the same with manual. And then for color, I chose 1, 2, 3, 1, 2, 3, black, red, green, 2 times. And the point character is 0 or 1, indicating a square or a circle. But as you can see, this is a bit cumbersome, and the ggplot function makes all of this a lot easier, and I'm going to show you how to use the function arguments there next. Moving on to the ggplot function. This function is available within the ggplot2 package, so use library to load it, or load the whole tidyverse package, where you can see ggplot is included, as well as tidyr or readr. If you don't want to have this default gray background in your ggplot charts, you can change the theme to light with the theme set function, and then it looks like this. And usually I pipe the dataset into the ggplot function, where the first argument is the mapping, and the aesthetics for this mapping are a basic X and Y coordination to the weight and MPG column. And then I add the geom point with a slightly increased size of the dot. Now you can use a constant color for all of the dots by just specifying the color names. For example, you can set it to orange. But instead of using a constant color for all of the dots, you can map a third variable to the dots. For example, setting it to a continuous variable like the horsepower. So now within the aesthetics mapping, you not only specify the X and Y values, but you assign the whole HP column to the color function argument. And then you see the higher the horsepower, the brighter the color gets within this blue gradient. So these cars with a darker blue have fewer horsepower. And you can see as the engine size increases and you have more horsepower, the weight increases. But then also your gas mileage gets smaller. Doesn't really matter where you do the aesthetics mapping. You can do it in the first ggplot function, or later within the geom point function. But then it's important that you don't write color equals orange, but use color within the aesthetics mapping function again. And you could even add a force variable, again the automatic or manual shift. You could map this column as a factor to the shape function argument within aesthetics mapping, and then you would get a triangle for manual gear shift and a circle for automatic gear shift. Now, instead of mapping the color to a continuous variable, what happens when we want to change the color depending on a categorical variable like cylinders? 4, 6 and 8? Well, first you get a color gradient again because it assumes 4, 6 and 8 are regular numbers. So now the more intense, brighter colors match the 8 cylinders and the darker ones the 4, and you have 6 in between. But it's not the easiest way to differentiate between these 3 different categories. So what you can do instead is to use the S factor again for cylinders. And now ggplot knows that it's actually just the 3 levels available, 4, 6 and 8, and it treats them as characters or factors and giving it the first 3 default colors. There's one thing I want to mention briefly, which is overplotting, and the iris dataset has 150 observations, so rows of 5 variables. One of them is the species name, which comes as a factor with 3 different levels, but it could also be a character. And if you hand over this to the ggplot function and match the color to the species, you will get this plot. But what's not really obvious is that sometimes there are individuals that have the exact same sepal width and sepal length, and there are 2 ways you could make those visible. One is by introducing an alpha value, constant one of 0.5, and alpha increases the transparency. So now every time you have a darker dot, it indicates that there are actually 2 dots overlapping. But what I prefer to do is to add some jitter, so not using geom point, but geom jitter, additionally with some alpha value. So when before you had multiple dots overlapping here, with the geom jitter function, it will add a little bit of noise in the X and Y dimension, and then the dots get spread out a little bit more. The default shape for ggplot is 16, but if you want to use a different color for the outlining stroke and the filling color, you would have to use point characters 21 to 25. And if you use shape 1, you would get this circle that's not filled inside. Shape 16 gives you the filled in circle when you use color. And shape 21 would give you a circle again, but now this time you can actually fill it with something. So here you could choose fill equals gray, and it would fill the inside with gray, but keeps the color of the cylinders for stroke. And you could increase the stroke size with the stroke function argument to make it a bit more visible. So these are options. For geom points, there is a fill argument, but it only works with certain shapes. So this means in theory, you could again use 4 different columns to visualize your data using point character 21 and matching the color to the cylinders, red, green and blue strokes, but then using the horsepower to fill in the circles with increasing blue brightness for higher horsepower. But then again, there might be an alternative using the shape argument mapped to the cylinders, where you have circle, triangle and square, 4, 6 and 8, and using the color differentiation just for the horsepower. Or instead of horsepower, you could visualize the gear shift again, automatic versus manual with different color, and keeping the shape for the cylinders. In this context, I think it's important to show you a quick fix for the legends. So this is the chart coming from here, where it will use the mapping that was actually done within the legend. So color was mapped to this as factor AM, and shape was mapped to this as cylinder. And when you use the labs function, there's all kinds of things you can change text-wise. You can give it a proper x-axis label of weight in 1000 pounds, the miles per gallon as the MPG. You can use a title and subtitle. And now you have to remember what you used for what. Color was used for automatic or manual transmission. So within the labs function, you can hand over the text you want to use for the color function argument. And then it will realize that this is the text you want to override, the S factor AM, and then use \n for a line break to change this to automatic/manual transmission. And the shape was used to map the cylinders. So now within the labs function, use the shape argument to override your label for the cylinders. And the caption always goes at the bottom. It can be useful to change the color of your dots based on some condition. For example, let's highlight every car or respondent that falls within a certain range of gas mileage. So everything that's 15 or above and below 20 could be colored blue and the rest in red. And this happens automatically when you do the mapping based on the condition. It works the following way. You can ask whether the mileage is 15 or above, and for certain values this will be true. So everything past the 5th item is a mileage that's above 15. You can ask whether it's below 20, which is the case for all of these cars here that are smaller than this, and then you can combine it with the ampersand to get only the ones that fall within this range. And trues get coded as ones and false as 0, and when this is then used for the color, you get blue or red. And a plot like this. And this method can be used for some really cool effect. For example, this chart where you have some value on the y-axis that's either below 0 or above over 200 years. You can create a column that's either positive when it's 0 or above, or negative when it's below 0, and then use this column to map it to the fill argument or color for the geomCol function. And this will turn everything below the line that you can add with geomHline as the intercept of y at 0, and everything that's below that is a negative red, and everything above a positive bluish value. Next, I want to introduce you to the scale functions that help you to change the colors of your plot very quickly and conveniently. Now I want to talk about the different scale functions. Don't be intimidated, there are quite many of them, but they are supposed to make your life easier, so just look at the following examples. And keep in mind that when you assign the color argument in ggplot, you will have to use the color version of them. When you assign the color to the fill argument, you will have to use the scale fill functions. Let's start with a basic example. Here I created a data frame called ABC with 3 categories and 3 values. The structure is that you have some numerical input and characters, ABC. And when you put the category on the x-axis and on the y-axis you put the value, you can create this bar chart with the geomCol function. Since it is a bar chart, we cannot use color to assign an aesthetic mapping to the category, but we have to use fill. And if we use the ABC category, it will fill them with different colors to show that they are discrete and different from one another. If you would put value, so 2, 3, and 5, to fill in the bar chart, it will notice that this is now not discrete categories, but continuous variable, and it will automatically fill it with this continuous gradient going from dark blue to light blue with increasing value from 2 to 5, because the value column holds numerical data. There's something interesting happening when you go from character values or factors to ordered factors. So imagine you turn the characters ABC into a factor with ordered levels, C bigger B and B bigger A. When we store that as category 2, you now see that there is an additional column with ordered factors with these 3 levels. And for this, R will apply a special palette of colors that come from the viridis package. And here the colors are distinct from one another, but they also represent a gradient that reflects the order of the levels. You might be familiar with the diamonds dataset that has many ordered factors like cut, color, and clarity of the diamond. And if you plot that, you will see that it gets from dark to light over a gradient of improving cut from fair to ideal. This becomes even clearer when you plot the clarity, and then you see this nice gradient of improved clarity. As I said, when you have a bar chart, you have to use fill to assign a color. If you want to plot points with the geomPoint function, then the category you want to map to can be assigned to the color function argument and not fill. The rest is then identical. If it's an ordered variable, you will get these colors. If it's continuous, you will get this color filling. Now the first scale function I want to show you is the scale fill gray function that gets rid of the color. It does not work with continuous variables, so it needs a discrete scale. And if we want to match the color based on the value, which is a continuous variable, it won't work. But if we change that to the category, you get this grayscale. Within the scale fill gray function, you can specify the start and the end point. 0 would be represented by black and 1 by white. So you can play around with the spread of the grayscale, and you can also change the direction. If you go from 0.6 to 0.4, it's now a more narrow grayscale, and it goes from lighter values to darker values, as you can see here. The next useful function is scale color manual. I created this scatter plot with the iris dataset, and I assigned species to color for the dots here, and I saved this graphical object in a variable p, because now we can use it with different scale color options. For example, you could manually assign the values orange, green, and blue to this object with the scale color manual function, and then it will change the colors to orange, green, and blue. You can also use colors that are specified by the hex code, and within the scale color manual function, you're also able to change the labels of your plot. So this is the standard label, but you could change it within the scale color functions. Now you remember from the empty cast data that we had 4, 6 and 8 cylinders. Those are numeric, hence you get the gradient of colors, but we can turn them into factors like this. And then you could follow up with the scale color discrete function, because now it's discrete values and not a continuous variable anymore. And here you can use the type argument to assign hex code colors to the updated plot. And here I want to show you another cool function argument of these scale functions, where you can set the color of NA values. Here we just create a copy of the cylinder column called cylinder 2, and 5 of these values will be set to NA. So now at the end we have cylinder 2 with missing data. And if you plot that, by default, NA values will be gray. And when you want to change the colors, you could use the scale color discrete function, assign the 3 new colors you want to use, and then specify that you want the missing data to be black. So now it looks like this. And in combination with the scale color gray function, you could actually make the missing values stand out quite a bit more, because now all the distinct colors will be on a grayscale, but the missing values that you specify with NA.value, you can set it to red, and then those become much more obvious. There are some additional scale functions that don't come with the standard ggplot package, but for example in the library ggridis, there's the scale fill cyclical function, where you can plot your data but then override the colors in a cyclical manner with 2 alternating colors, going from dark red to dark green and then repeating. Now the scale color U function gives you a lot of freedom to create your own colors based on a 360 degrees color wheel. I can link to the article on Wikipedia that discusses the HCl color space in more detail and explains the hue, chroma and luminance. What you can always do is using the help function or question mark on the function and then scroll down and run the examples, because with those examples you can see what happens when you run the code and then change, for example, the luminance from 40 to 70. It gets a lot more cloudy, and when you increase the chroma, the colors get a lot brighter again. And here it changes just age, so the position on the color wheel, where you first are in the reddish values, then moving to the greens, blues and then pink colors, just like on the rainbow. Moving on to the scale fill continuous function. So imagine you have the annual temperature of the 50 US states. You can plot the data with the plot US map function and you get this coloring by default. In the next charts I'm going to remove Hawaii and Alaska and then use the scale fill continuous function to set a different color gradient. So what I did here was use the exclude function argument and then follow up with the scale fill continuous, where you provide a color for low and for high temperatures that represent the borders of your gradient. You can use name to assign the scale some nice labels, and then use labs for a title, and with theme legend position you can put the gradient to the right. Now in this example I used the scale fill steps n function, where again you provide 2 colors, one for the lower boundary and one for the upper boundary, light green and red, and then you can provide the n.breaks, here 7, that turns a continuous gradient into distinct steps. So now there are only 7 different colors used for these 48 states, and it makes them a bit more comparable, noticing where the average temperature is below 45 degrees Fahrenheit. You can use the scale fill gradient 2 function, for example, if you want to provide a midpoint. So here I looked into the median of the different temperatures being at 51.2, and I used this for the midpoint setting. Reason being that I want to go from low temperature in blue to high temperatures in red with a midpoint in white. So now we know the midpoint is the median, and every state that's below average gets a bluish color, and every state that's warmer than the median gets red, with then Texas and Florida being the hottest. Here I sorted the different temperatures, because when I look at Florida it looks too red for my taste. And here within the scale fill gradient 2 function you can also provide limits from which temperature to which you want the gradient to work, and if you change the highest point from 70 to 80 the gradient gets wider, but then the color differences aren't as sharp anymore and it looks a bit more pleasant. There are 2 more scales function I want to talk about. One is the scale color viridis function that comes from the viridis package, and it's quite a powerful tool because it comes with 8 distinct options that represent different scales or gradients of colors you can use that are pre-designed to work really well with maps or charts. And the first thing you should notice is that they come in 3 different versions depending on the underlying data. So when you have discrete, categories, whether they're ordered or not, you should use the scale fill viridis _d function. If you have continuous data, use C, and if you want to bin continuous data, use _b. They come with a function argument called direction, and if you set the direction to -1, it will flip the gradient, now going from yellow to purple, where by default it's purple to yellow. And they come with the options function argument, where you can set it to 8 different options, one of them being plasma, to turn it into this. And the geyser dataset from Old Faithful from the Yellowstone National Park is a good example to show you the different options of the viridis palettes. It measures the eruption time in minutes and then the waiting time for this eruption. And with this code, you would be able to create this plot. This shows you the density of eruptions depending on the waiting time and then for how long they last. So you could see there's some pattern going on. And here are the 8 different options you can choose to change the color gradient of the charts. And it doesn't matter whether you write option equals A, B or C, or use the specific names like magma, inferno or plasma. And as I said, there are 3 different versions of these scale functions. And if you use B for binned data, it would turn this smooth gradient into only a few binned steps. Lastly, I want to talk about the scale colorBrewer function. The RColorBrewer package provides different palettes, and most importantly, they come in 3 different types: sequential, diverging, and qualitative. So you can use them for categorical variables or gradients or colors that diverge into 2 directions. In the description below, I will link to some websites that give you a good overview of the package and the different palettes you could choose from and how to use them. One thing you can do is run the code displaybrewer.all, and it shows you qualitative datasets where the colors are different from one another, the diverging ones that have a white or yellow center point and then diverge into 2 different colors of opposite spectrums, and then sequential colors that go from a light blue to dark blue or within green or move from yellow over orange to red. Also with this function you could actually set the type to diverging, sequential or qualitative and then only look at those color palettes. And you could also limit the number of colors you actually want to see within a certain type of palettes. And then there's also an option to only look at the color blind friendly palettes. So what can you do with this now? You can use the brewerPal function, select the palette and the number of colors you want to get, and then it will give you the hex code of those colors. And this is a way to create the colors with the hex code, store them, and then use them in an image just to display what the colors would actually look like. So here I selected 7 greens. Then you can create 12 colors from the palette called set3 for qualitative color differences. If you only use 6 colors from this palette, you'll get the first 6 only. And then from red, yellow, green, you could create a gradient of 11 colors, or for red, blue with just 7. So then how would you use the function? Just as before, you plot the data, check whether you used fill or color, and then use scale fill brewer or scale color brewer. And then you can specify set 1, 2 or 3, and it will just use those colors and override it. It also conveniently comes with the type function argument, where you can just choose between sequential, diverging and qualitative, and it has the directions again with 1 or -1 to reverse the color order. Remember how before we created these hex codes for colors and then used image to show them how they actually look? There is a function called show_col from the scales package, where you can hand over any vector of hex codes and it will show you how the colors will actually look. So here these are 12 colors from the viridis turbo option, but you could also show 20 of them. You could change the direction from purple to yellow, yellow to purple, and you can also narrow down the spread of the color differences. So yeah, if you use beginning and end and you change it, you can make this gradient a bit more smooth, getting rid of the extremes, 0s and 1s, which are the purples and the yellow, and only using colors that are closer to one another. You already saw 2 methods to call out a color in R. One is by the name and another one is by this 6-digit hex code that follows a hashtag. There's however a third option how you can specify a color or generate this hex code. You might have seen that in PowerPoint, where you can change the color by these RGB values. And if you set all the 3 channels to 0, then there's neither red, green or blue expressed, and you get black, which is coded by 6 zeros following the hashtag. If you put all of them to a maximum, you get white, expressed by 6F. And if you only express one channel, you get red, green or blue. And if you start mixing them, you get a combination of both lights turning red and green combined to yellow. Now imagine you want to create some kind of orange and you put in these numbers. This is the hex code you would get, and there's actually a function in R that can do that. And this function is called RGB, where you have to provide values for red, green and blue, and you could choose some alpha for transparency. And by default, the expression of the channels is percentage based, so it would go from 0 to 1. And as I said, if you turn everything to 1 or 0, you get white or black. If you only put it to 50%, you get some kind of gray. And in the PowerPoint version, we try to create this kind of orange, which then spits out this hex code for this color. And here I turned the max color value from 1 to 255, because that was the setting in PowerPoint. If you want to add transparency to a color, you can do that by providing an alpha value, and this will add 2 additional digits at the end of the hex code. Keep in mind, if you set alpha to 0, then the color won't be expressed. It's completely transparent. And if you set it to the max value, the color will be 100% expressed, as if you wouldn't have provided an alpha at all. There's another function called call to RGB, where you do the opposite. You provide a name of the color and it gives you the RGB values. So a dark red has 0 for green and blue, and then some expression of the red channel. And a light blue would be generated with these values. So you could then enter those into the RGB function to get the hex code. You could also enter multiple column names at the same time to get the results in this matrix format. And there you can also name the columns within the function, so you don't forget which values correspond to which entry. You remember that the colors function gave you all the color names in R, and with these lines of code, you can actually generate a matrix where every color name gives you the expression of the red, green and blue channel. In this way you would learn that navy and navy blue is the exact same color in R. And just as a reminder, when we created this type of orange with the RGB function, we got the hex code, and if we enter a hex code into the color to RGB function and not the name, it will then return the values. Another useful function I want to mention is the colorRamp function that allows you to do color interpolation. So just provide the names of the colors, and then in parentheses you provide the number of colors you want to get in total on this gradient. So this would be a gradient from blue to red with some in-between colors of 2, but you can also provide a middle color, so it's supposed to go from blue to white and then to red, and you want to get 11 colors. So the midpoint is the expression of all channels, which is white, and here it starts with blue and ends with red. And these gradients can be useful for 2-dimensional density charts, as expressed here by the filled contour function, where the color palette is provided by this colorRampPalette. You can also use this function to create some transparency increases. So imagine you just have a blue color to start with and a blue color to end with, but you change alpha from 1 to 0, so making it more and more transparent. Within the colorRampPalette function, you set alpha to true. And now if you want to get 8 colors, you see that the first 6 digits are always the same, but then the alpha value decreases in 7 steps until it's at 0, 0. And if you use this color ramp on the previous image, this is the gradient you would produce. And if you are a MATLAB user, then the jet colors that are there by default could be created with this colorRampPalette function, where you specify 9 distinct colors that are then presented here at different steps, and the rest of the colors are interpolated. Now I want to show you how you can use color information to replace a legend. So this is information on 3 penguin species, and instead of looking up the blue color related to this species, you can create a chart where you talk about the 3 different species and include the color information already in the title name. And in this way you can create a really nice chart. The basic chart is created this way, just plotting body mass versus flipper length and then color the species information. And then I use the scale color manual function to change the default blue, green and red into these colors based on their hex code. And if you want to use color information in the ggplot title, you have to install the ggtext package, because this allows you to use markdown styling. Within the labs function, I included color information for the subtitle. So that's the text that's a little bit smaller than the main title. And here I used basic HTML coding. So after a line break, I start this tag, and within the tag you can use style equals color and then include the hex code for this color, followed by the actual text. And then you repeat that for the other 2 species with the colors you used before, And then one very important thing is that within the theme function, you have to say that the plot.subtitle is now an element underscore markdown. And then it will translate this styling information into an actual color. There's one last example I want to show you where color holds very important information on the data that's presented. So for example, here I have data points that correspond to two different items within the same chart. And for that you have two different y-axes. And by coloring one in red, it's clear that this red line represents $1 billion spent for science, space and technology in the US. And the black color is used for the second y-axis that shows suicides over 10 years. And the code you can find on my GitHub channel, and I will link to that in the description below. It's just one thing that's important. It's based on this extra package called ggh4x that has a function to create a secondary object. It's using a help secondary function where you specify what the first y-axis and the second y-axis are supposed to hold. And then you use this object to create an additional chart. So first you would create a normal line plot and adding the points, and this would go on the first y-axis. And then you add to that chart another line and more points in the color red based on the sec object that you created before. And then you can combine both, and then it's just minor thematic changes where you can color the left y-axis in red and keep the rest in black. And here again I did the HTML style coding for the title within the plot annotation function from patchwork package. And then within theme you have to again use the ggtext element markdown function to tell the chart that the plot title will contain HTML information and should be compiled with this markdown function. So then that's another way to use color to get a point across. And lastly, I want to talk about an amazing package called the Paletteer package that comes with a website where you can scroll through hundreds of different palettes that come from a variety of different packages and are compiled here. And it looks a little bit overwhelming, but you can actually just filter for certain palettes. So you only want to see qualitative ones or divergent palettes that go into two different colors. What you can also do is sort by length, where it would start with the palettes that have only a few colors, but you can also sort decreasing, and then you get these really smooth gradients, as well as for sequential color palettes. You can search for specific palettes. For example, there is one that is based on national park colors, and these come from this GitHub package. And now the advantage is that you don't have to know about these individual package, because on the Paletteer website you can just find them more easily. And here the author of the package created different palettes based on images that were taken in different national parks throughout the US and Canada, and they just look really nice. Some are from France, so it's all over the world, and some even from South America. There's also a palette that's based on Wes Anderson movies, and if you select one, it will usually link to the GitHub page where you usually find the information of the origin of these palettes, and most of the times it's based on individual images of the movies, and then relevant colors were selected to create these palettes. Same is true for Beyoncé color packages. Those are as well based on different images that were then used to create these palettes. So yeah, try this out for yourself. There are Taylor Swift palettes. You find Dutch painters that come in different styles. So just look for one that you think would make your chart look more interesting or more pleasant. Here's how you would actually use them. If you select a package, then with this code, so here I selected this palette from the pearl earring painting from Vermeer. And if you run this code, you would get the colors of the palette. And there's a scale color paletteer or scale fill paletteer function where you just specify the palette name. And then you could specify for palette you want to have Dutch Masters pearl earring, and it simply applies the color palette to your chart very conveniently. Thanks for watching this video here at the Data Digest. This has been the first upload I did ever since my mother died 3 months ago. She would always watch my videos, even though she did not really understand the topics. But she said that hearing my voice made her feel that I was close to her. And with this memory and tears in my eyes, I dedicate this video and everyone that follows to her. Bye bye.